Hello students, welcome. Previously, Form 2, Topic 3, Lesson 3, we were dealing with covalent bonding or covalent bonds. Then we were dealing the first example, example 1. We have done part A, part B, and also part C. So today, lesson 4, we want to proceed to the first question, but D, E, F, and also G. The D or question D, that's carbon dioxide. So when you see carbon dioxide, the way we write carbon dioxide is made up of carbon and oxygen. So first of all, we are supposed to know how to write carbon dioxide. It's written CO2. What does that mean? We have one carbon and we have two oxygen. So the electronic configuration of carbon is 2,4, the one for oxygen is 2,6. So we are going to draw, we can give this carbon cross, we can give oxygen dot. Then we are going to draw the bonding. Carbon is 1, so we are going to put carbon inside, in the middle. Then we are going to link it with 2 oxygen, because oxygen is 2 the way you see the formula, and this is the other oxygen. So the chemical symbol of oxygen is O, we can shade, or we can write O. Even we can shift carbon here, or we can write the way it is like that. So we start again. We said for this carbon to become stable, how many electrons does it require? It requires 4 electrons. So those 4 electrons are gained from oxygen. So when it's gained from oxygen, we are going to take 4 dots to the shared part. So carbon has 2 linking. One is here, the other one is here. So that means we put 2 here, 2 dots here, then we put another 2 dots here. That's what we are supposed to do. Then we go to this oxygen. We say for this oxygen to become stable, how many electrons does it require to accept? Only 2 electrons. So those 2 electrons will be gained from carbon. So carbon is having cross. So that means this is oxygen. It requires 2 crosses from that carbon. And this is also oxygen. It requires 2 crosses from that carbon. So we are done now. Because this is oxygen and this is also oxygen. So this one requires 2 electrons from carbon. Even this one requires 2 electrons from carbon. So that's how we are going to draw the one for bonding. So let's just try to see whether the outermost energy level is full or not. We start with the first one. The first carbon was having 4 crosses. When we check here, I have 1, 2, 3, 4. So carbon is complete. It is outermost energy level. In total, it's supposed to have 8, 4 which is cross, and 4 which is gained from oxygen. This is 1, 2, 3, 4 in the first linking, 1, 2, 3, 4 in the second linking. In total, it has 8 electrons in its outermost energy level. So we go to oxygen. Oxygen has 6 crosses and it is outermost energy level. Let's confirm. So you have only 1, 2. So it requires 2 there, another 2 there. In total, so we have 1, 2, 3, 4, 5, 6 dots and 2 which it has gained from carbon. We go to the other oxygen again. Same, it's supposed to have 6 dots, but I have only 2 dots. So I have to add 4 more dots to complete its outermost energy level. So when I count 1, 2, 3, 4, 5, 6 dots and 2 crosses gained from carbon. So if we want to represent the other way, we can put first of all carbon in the middle. Then we have 2 crosses and 2 single. So that's double bond with oxygen, this oxygen here. Then we can have 2 crosses and 2 dots. That means double bond with the other oxygen. So this is how the bonding of carbon dioxide will look like. So we're going to see the answer here, the way we have drawn it. It's the way that I've explained now. You can just have a look at it. So we're going to go to E, that's ammonia gas. So when you write ammonia gas, its formula, it is NH3. What does that mean? It is 1 nitrogen in the middle bonding to 3 hydrogen. That's what you are supposed to see from there. Bonding to 3 hydrogen. So all of these ones are hydrogen. Then the elements there are nitrogen and also hydrogen with electronic configuration of 2, 5 and electronic configuration of 1. We can give this one cross, we can give this one dot. So we start with nitrogen. For nitrogen to become stable, it requires only 3 electrons to gain. So that means those 3 electrons will come from hydrogen, despite having the electronic configuration 1. But remember, we have 3 hydrogen. So that means each will contribute 1. So we are going to have 3 dots. So that means, you see, nitrogen has 3 shared parts. Each will be placed in 1 dot like that. Then we go to hydrogen. We said for hydrogen to become stable, it requires only 1 electron, and that electron will be gained from nitrogen. That's 1 cross. So where you see hydrogen, we put the linking 1 cross. This is hydrogen, we put 1 cross. This is hydrogen, we put 1 cross, because hydrogen requires 1 electron to accept from nitrogen, which is cross. So we're done with the bonding. We have to confirm the atom's energy level. We start with the nitrogen. It's having 5 crosses, but I see only 1, 2, 3. So that means the other 2 will be placed there. So if you confirm 1, 2, 3, 4, 5 crosses, then 1, 2, 3 dots. That's complete. We go to hydrogen. Hydrogen was having 1 dot. So 1 dot, and it has gained that. 1 dot, it has gained that. 1 dot here, it has gained this one. So that means it is correct when we do like that. Check the answer here. It's the same as what we have done. So this was the 2 electrons that we are talking about. In this example, they have given nitrogen dots, they have given hydrogen cross, but the 2 are one and the same. You can just try to give a nitrogen cross, or you give nitrogen dots. So we go to question F, that is ethane. It's written C2H6 Solanus. The structure that we have here is ethene. It's written C2H4, the way you see, 2 carbon and 4 hydrogen, the way you see. So the one for ethane, we are going to explain it here. So when you see ethane, we have 2 carbon being bonded together. So this is the first carbon, it's linked to the other carbon. So we are having like that. So each carbon is having 3 hydrogen. This is 1 hydrogen, 2nd hydrogen, and this is the 3rd hydrogen for the first carbon. We do the same here. The first hydrogen, this is the 2nd hydrogen for the 2nd carbon, and that's the 3rd hydrogen for the 2nd carbon. So what we are going to have is carbon bonding to another carbon. So carbon with carbon, we give the first carbon cross, the other carbon we give dot. Remember, carbon has an electronic configuration of 2,4. So for this carbon to become stable, it has to accept or gain 4 electrons from this other carbon, which is dot. So we're going to have 4 dots in the shared part. So this carbon has 4 shared parts. This is 1, this is 2, 3, and this is 4. We're done. We'll go to the other carbon again. So the other carbon has 4 electrons in the atom's energy level. So it requires 4 electrons to become stable. So it will gain that 4 electrons from this other carbon, which is cross. So we take 4 crosses to the other side. So this is the other carbon, 4 crosses. This is 1 cross, 2nd, this is 3rd, and this is the 4th cross. We are done carbon to carbon. We are going to go next, hydrogen to carbon. So hydrogen will be given dot, because carbon has been given cross in the first carbon. So hydrogen will be the one that's having dot. So hydrogen has to gain 1 electron from this carbon, which is cross. So when we see hydrogen, we are going to put 1 cross there. When we see hydrogen in the first carbon, we are going to give 1 cross. So in the 2nd carbon, remember we have given it dot. So hydrogen will be given cross. So you know hydrogen has only 1 electron. So for it to become stable, it requires 1 more electron. So that electron will be gotten from this carbon, which is dot. So when you see hydrogen, we add 1 dot. Hydrogen, we add 1 dot. Hydrogen, we add 1 dot, like that. 1 dot there. So this is how the structure of ethane will look like. If you want to draw the other way around, but before that, let's confirm the atom's energy level. The atom's energy level of the first carbon is having 4 cross. 1, 2, 3, 4. It's okay. It has accepted 4 dots. 1, 2, 3, 4 from the other carbon. Okay, when you check the other one again, the other carbon was having 4 dots. You see 1, 2, 3, 4 dots like that. So if you want to draw it the other way up in the structural formula, we can have carbon, and that's a single covalent bond to the other carbon. Then when we start with this first carbon, it's having 1, 2, 3 covalent bonds, and we are going to have hydrogen in every place. Then when we check this other one, it's having a carbon to hydrogen 3 covalent bonds, like that. This is how the open structural formula for ethane look like. We're done with that. So kindly don't use this. This is for ethene, not ethane. Ethane, I've drawn it here. This is it. So we go to G. G, we have silicon 4 chloride. It's written SiCl4. So remember, we want to do something like that. Si, then we are going to put 4 chlorine. Like that. So let's start. We write Si, and we write it is outermost energy level. Then we link with 4 chlorine. This is 1 chlorine, 2nd chlorine, 3rd chlorine, and this is the 4th chlorine. So we start. Silicon is number 14 with electronic configuration of 284. Then chlorine is number 17 with electronic configuration of 287, like that. So we give silicon cross, we can give chlorine dot. Okay, the way we are going to use in this structure, it is silicon which has been given dot and chlorine has been given cross. But as we are going to do it, silicon for cross, chlorine for dot. So we are going to go. We ask ourselves, for silicon to become stable, it requires 4 electrons, and those 4 electrons will be gained from chlorine, which is dot. So silicon has 4 shared parts, so we give each 1 dot, like that. 1 dot, 1 dot, 1 dot. We go to chlorine. So chlorine requires only 1 electron to gain from silicon, which is cross. So when you see chlorine, you only put 1 cross. This is chlorine, 1 cross. Chlorine, 1 cross. This is chlorine, 1 cross. You are done. Let's confirm. The outermost energy level of silicon was having 4 crosses. 1, 2, 3, 4 crosses. So it's okay. Let's go to that of chlorine. It was having 7 dots. Let's check. It was having 7 dots. So 1 dot. So we are remaining with 6 more dots. 1, 2, 3, 4, 5, 6. So it was having 7 dots. Initially 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Then 1 has been gained from silicon. So this one the same again. So I have to add 7. I have to count 7 dots. This one is not there. That one was cross. So 1, 2, 3, 4, 5, 6, 7 dots with 1 cross. Here the same. So what we had, we are going to add only 6 dots. And this is another chlorine. We're supposed to do something like that. So that's how we are supposed to draw silicon 4 chloride. So when we check the diagram here, this is silicon. It's given dots. So we're having 4 dots inside. It is paired part. Then it has gained 4 crosses from chlorine. Then each chlorine check is having 7 crosses. 1, 2, 3, 4, 5, 6, 7, and it has gained 1 dot from silicon. This the same, this the same, this the same. We'll go to the next part, learners. We are told extended questions. Question 2. Use dots and cross diagrams to show bonding in the following compounds. So we are supposed to look for chlorine molecule, methane, water, and also silicon 4 oxide. We have given you the formula for these compounds. Okay, that's the end for today. Thank you for watching.